Hello friends, welcome to Truth of Physics. In this video, I will discuss what will be the change in entropy in the process of Joule expansion or free expansion. So firstly, in this video, I will discuss what is the Joule expansion, what is this process, Joule expansion or free expansion, what is it? And after that, I will also discuss what is the change in entropy in this process. So you can see that here this is two compartments of same volume. Suppose the volume of these two compartments is same, and that is V. And the first compartment, this is our first compartment, this is filled with 1 mole of ideal gas, suppose. And this second compartment is totally evacuated or totally empty, and okay, that is, this is vacuum. And you can see that here is a barrier between these two compartments, and we externally can open this barrier, open or close this barrier, okay. And this total system, this is our system, this total system is kept thermally isolated. That is, there cannot be any exchange of heat between the system and the surroundings. That is, there cannot be any exchange of heat between the system and the surroundings. That is, del d bar q is 0 here, okay. Now if we open this barrier, if we suddenly open this barrier, then what happens? Then suddenly these gas molecules will start to fill all over the volume, that is all over the volume 2V, that is fill all the two compartments, both the two compartments, and we have to find the change in entropy in this process. That is the change in entropy in this process. And what is this process? Our initial condition was V. Our initial volume of this gas was V, and our final volume is what? 2V. This expansion of gas against the vacuum is called the Joule expansion under this circumstances, that is under this, okay, thermally isolated. And this process is what? This process is, as we have suddenly opened this barrier. So this process, the expansion of this gas, this process is a non-static irreversible process, okay, non-static irreversible process. I think that you all know that what is irreversible process, okay. So what will be the change in entropy, okay. Now we know that del S is equal to del Q or d bar Q by T, and del S is greater than d bar Q by T, right? And this is what? This is for what process? This is for irreversible process. Irreversible process, and this is for reversible. This is for reversible process, and we have previously discussed that this process is what? This process is a irreversible process, okay, and non-static irreversible process. So here what condition will be valid? This condition. Here we cannot use this condition, and we cannot use this condition, and the result will not be equal to 0. That is, if you think that here dq is 0, so if we put in this equation, then it will be, the changing entropy will be 0, but this will not happen, because this formula is wrong, because this is a irreversible process, okay. So we have to calculate the change in entropy in this process, because this is an inequality, this is not an equation, and we cannot find the exact change in entropy, that is, we cannot find the exact del S in this process. Yes, we can say that in this process there is a the change in entropy is greater than 0, that is, there is a change in entropy, and that is positive from here, but we cannot exactly find what will be the exact value of the change in entropy. So for this we have to put a property, and that is, our entropy is a state function. That is, our entropy S is a state function, and I think that you all know what is the state function. State function means that in this process, during this process, the change in entropy del S is only dependent on the two endpoints, that is the final condition or the final state and the initial state. It doesn't depend on what path we follow, that is what is the process by which this what is the process in this expansion. That is, what is this? Suppose this is our p axis and this is our v axis. Okay, now suppose here is the position of volume v, that is this corresponding to our volume v, this length is v, and suppose here is a point 2v, that is this corresponding to the length 2v. Okay, now these are what, this point and this point is what, the two end points or the final and initial conditions, final and initial states of this process, this Joule expansion, that is 2v and v. Okay, so suppose the gas is followed by this path, or the gas follows this path. This is our Joule expansion path. The gas of this compartment of volume V is following this path, this Joule expansion path, and after this expansion the gas is expanded in volume 2V from volume V. So this is justified. Okay, now what is the main difficulty of finding del S? Why we cannot find del S? Because the process is irreversible, because this Joule expansion is irreversible, and that's why we cannot find directly the change in entropy during this process. So, but we know that S is what? S is a state function. S is a state function, that is del S is dependent only on the two endpoints, and our difficulty is only in the irreversible process. So can you imagine just these two things? Can you connect these two things? The solution of this problem is, as del S, as S is a state function and del S is dependent only on the two endpoints. So if we think of another process which is connecting the two endpoints, the same two endpoints, that is, if we fix these two endpoints V and 2V and consider another process of expansion of gas, and the process is a reversible process, then what happens? If we consider a reversible process between these two endpoints or between these two states, that is, if we expand, suppose, okay, if we expand at 1 mole of ideal gas in an irreversible process, and after expansion, if the volume is 2V, then these final conditions are final and initial conditions are satisfied, and the process is another. Okay, the process is another and process and different process, and the process and this process we are considering is reversible. So the change in entropy during this process, that is the del S for this process, will be same and will be equal to, will be same to this process. Okay, because the two endpoints are same. The same, these are the two endpoints, and these two endpoints are same. So del S will be same for both the two processes, for the Joule expansion process and for this reversible process. Now, for convenience, we consider this a reversible process, this reversible path or this reversible process, as an reversible isothermal expansion. Reversible isothermal expansion. And so now our motive is what? Now we have to find the del S for this process, isothermal reversible process, by this equation, because this is an reversible process, this is reversible process, so we can easily find the del S. And when we find the del S, then if we put the del S for this irreversible process for our Joule expansion, then that will be satisfied, because the del S will be same for the two processes, because S is a state function. Okay, I think that you have understood what I am just want to explain you. Okay, now what will be that? What will be our del S in this isothermal expansion? Now del S is equals to dq, d bar q by T. From here we can write for the expression of del S for an reversible process, and we know that d bar q is what? From first law of thermodynamics, it is du plus p dv, that is the work done. And we know that as this process is isothermal, this path is, the gas is following this path, and the path is isothermal expansion. And we know that isothermal expansion is what? T is constant, and as T is constant, we know that for ideal gas, del U must be constant, U must be constant and del U must be 0. So as this is an isothermal expansion, so T is constant, and as T is constant, for real gas, we know that du is 0. So du is 0 here, du is 0. Now we have to calculate this. This will be ds, as this is for infinitesimal infinitesimal path. So if we just integrate this, so this will be what? This will be just S2 minus S1. That is, this is what? This is nothing but our del S, the change in entropy between the endpoints, between the final and initial state, and this will be equal to what? This integration p dv by t, and we know that what is p? Our p is equals to RT by V, as PV equals to RT, so P equals to RT by V. So if we put this, so this will be RLN2. If we put this here, so after integration, as this integration is from V to 2V, V is our initial and 2V our final condition, final volume. So this result will be just RLN2 if we calculate it. So our del S, our required del S for the isothermal expansion is RLN2, that is, this is constant. Okay, this is a constant RLN2, and this is nothing but this is the same for our Joule expansion. So for our Joule expansion, the change in entropy will be always RLN2, where R is what? R is our universal gas constant. So I think that you have understand all the concepts, that how we can find the entropy for this irreversible Joule expansion process by an equivalent or not equivalent and another process, okay, between the two same endpoints. So I think that all of these concepts you have understand very well, and if you have any doubts, so you can also comment me below. If you are new to this channel, then subscribe this channel and hit the bell icon for the latest notifications of our upcoming conceptual classes of physics. Thank you for watching.